But how does filtration work? It's often thought that our filters work as sieves, whereby the particles are larger than the pores of the filtration medium and are retained at the filter media surface. This is a misconception. Oil aerosol and dust particles in compressed air are much smaller than the media pores, so sieving does not occur. Instead, 3 different filtration mechanisms are at work. Each of these mechanisms is responsible for capturing particles of a particular size. The first mechanism is inertial impaction. The unclean air flows through the filter media, but the heavier particles don't follow the gas flow streamlines because of their large inertia. Instead, they travel along a straight path until they collide with a fiber and are thus removed from the air. Impaction becomes more important with increasing particle size. The second mechanism is called interception and involves particles of a somewhat smaller size. These are particles that are light enough to follow the streamline. But when the radius of the particle is larger than the distance between the streamline and the edge of the fiber, the particle hits the fiber. It gets stuck there and is thus removed from the air. Interception gains importance with increasing particle size. The third mechanism is diffusion, and this takes care of the smallest particles. These small particles do not strictly follow the streamlines. They move randomly due to collisions with gas molecules. We call this Brownian motion. Because of this erratic movement, they're bound to collide with a fiber. The smaller the particle is, the higher its freedom of movement, and therefore the higher the probability that it will encounter a fiber. Capture by diffusion becomes more important with decreasing particle size. The total filter efficiency is the result of the combination of these 3 filtration mechanisms.